Namaste. Very happy evening to all my dear students, teacher, and the school administrative department. We welcome you all to our Vidya Shakti science session. My name is Ashwata Malnar and I'm your science tutor. Children, how are you all doing? After a long time, you've been connected to our science session. So once again, welcome you all to the session. And in today's session, I shall be starting with the second term of your portion. Of course, you all may be having a question saying that the first term portion is yet to be completed, right? Don't worry. In a very crisp and short videos, we try to complete the first term portion, and these videos can be accessed by all of you by visiting to our YouTube channel. So you can visit the YouTube channel with the help of your teachers and the coordinators, and then access the short videos of the first term. Clear? As of now, we shall start with a new chapter of the second term, and the name of the chapter is The Matter in Our Surroundings. So, the matter in our surroundings topic has been related to this particular chapter, that is nothing but the atoms and molecules. Okay. So, what do you understand when I would tell the atom and molecules? Atoms ಮತ್ತೆ molecules ಬಗ್ಗೆ ಹೇಳಿದಾಗ ನಿಮ್ಗೆ ಏನ್ ಅರ್ಥ ಆಗುತ್ತೆ? Yeah, what do you understand when I tell atoms and molecules? So ಏನಾಗುತ್ತೆ ಅಂದ್ರೆ for understanding this, you have to know the actual meaning of this as per our Indian um, philosophers and Greek philosophers as well. So we all know about the matter, and the idea of divisibility of matter was considered long back in the India, maybe around 500 BC. 500 ಕ್ರಿಸ್ತ ಶಕಕ್ಕೂ ಮುಂಚೆ ಈ ಒಂದು ಮ್ಯಾಟರ್ ಬಗ್ಗೆ ಅದರ ಡಿವಿಸಿಬಿಲಿಟಿ ಬಗ್ಗೆ ಎಲ್ಲ ನಮ್ಮ ಭಾರತದಲ್ಲಿ ಚರ್ಚೆ ಆಯಿತು. ಸೊ ಭಾರತದ ಒಬ್ಬ ಫಿಲಾಸಫರ್, ಹಿಸ್ ನೇಮ್ ಇಸ್ ಮಹರ್ಷಿ ಕನ್ನಡ. ಸೊ ಇವ್ರು ಹೇಳ್ತಾರೆ ಮ್ಯಾಟರ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ ಪದಾರ್ಥ ಅಥವಾ ಪದಾರ್ಥ. ಓಕೆ, ಇದನ್ನ ನಾವು ಸ್ಮಾಲ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೋದು. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ದಿಸ್ ಇಸ್ ಅ ಮ್ಯಾಟರ್, ಯು ಕ್ಯಾನ್ ಇನ್ನು ಚಿಕ್ಕ ಚಿಕ್ಕದಾಗಿ ಮಾಡ್ತಾ ಹೋಗಬಹುದು. ಸೊ ಹೀಗ್ ಮಾಡ್ತಾ ಮಾಡ್ತಾ ಒಂದು ಸ್ಟೇಜ್ ತಲುಪುತ್ತೆ ವೇರ್ ದಿಸ್ ಬಿಕಮ್ಸ್ ವೆರಿ ಮೈನ್ಯೂಟ್ ಅಂಡ್ ಯು ಕಾಂಟ್ ಸಿ ದಟ್. So this particular thing, which is very minute, they call this as atom. Athwa paramanu. Okay, which is very small in the size. Okay, so when it becomes smallest of the smallest, so that cannot be divided further, and then it becomes the atom or paramanu. There was another Indian philosopher, his name is Pakuda Katyayama. Katyayama. Okay, he elaborated that this particles, okay, normally exist in a combined form, which gives us various form of matter. So he tells various atom together forms a matter ಅಂತ ಇವ್ರು ಹೇಳ್ತಾರೆ. ಅದೇ ರೀತಿ ಏನ್ಷಿಯಂಟ್ ಗ್ರೀಕ್ ಫಿಲಾಸಫರ್ ಡೆಮೋಕ್ರಿಟಸ್ ಮತ್ತೆ ಲೆಲ್ಯೂಸಿಪಸ್ ಅಂತ ಇದ್ದಾರೆ. They had told that if we go on dividing matter, a stage will come when particles obtained cannot be divided further. So, as Maharshi Kannad they said, even they came to the same conclusion. So, when we keep on splitting a particular matter, there comes a situation where it cannot be divided further. So, Democritus called this indivisible particles as atoms. So, the atom's name was given by Democritus, and he told this atom as indivisible matter. ಮತ್ತೆ ಅದನ್ನ ಡಿವೈಡ್ ಮಾಡಕ್ಕೆ ಸಾಧ್ಯನೇ ಇಲ್ಲ. ಸೊ ದೋಸ್ ಕೈಂಡ್ ಆಫ್ ಥಿಂಗ್ಸ್ ವಿ ಕಾಲ್ ಇಟ್ ಆಸ್ ಆಟಮ್ಸ್ ಅಂತ ಅವರು ಹೇಳ್ತಾರೆ, ವಿಚ್ ಇಸ್ ಇಂಡಿವಿಸಿಬಲ್. ಓಕೆ. So all this was based on the philosophical consideration and not much experimental work to validate these idea could be done till the 18th century. But ಈ 18th century ಕೊನೆಗೆ ಏನಾಗುತ್ತೆ, scientists recognize the difference between the elements and compounds and naturally became interested in finding out how and why elements combine, what happens when they combine. ಸೊ ಅಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ಗಳು, ಕಾಂಪೌಂಡ್ಸ್ಗಳು ಇದೆಲ್ಲ ಗೊತ್ತಾಗ್ಲಿಕ್ಕೆ ಅವ್ರಿಗೆ ಶುರುವಾಯ್ತು. ಅಂಡ್ ಈ ಎಲಿಮೆಂಟ್ಸ್ ಕಂಬೈನ್ ಆದಾಗ ಏನಾಗುತ್ತೆ ಅನ್ನೋದು ಅಟ್ ದ ಎಂಡ್ ಆಫ್ 18th ಸೆಂಚುರಿ ಕಂಡು ಹಿಡಿಲಿಕ್ಕೆ ಅಂತ ಶುರು ಮಾಡ್ತಾರೆ. ಸೊ ವಾಟ್ ಹ್ಯಾಪನ್ಸ್ ವೆನ್ ಎಲಿಮೆಂಟ್ಸ್ ಕಂಬೈನ್? To understand that, we have to understand laws of chemical combination. Laws of chemical combination. So ಏನ್ ಹೇಳುತ್ತೆ laws of chemical combination? Which says that a mass state that can neither be created nor destroyed in a chemical reaction. So as we tell for energy, energy can neither be created nor be destroyed. Who told these words? Ashwita madam, right? But who told these words in reality? And energy can neither be created nor be destroyed was told by whom? Who gave the statement? Very good. Albert Einstein gave the statement. Similarly, law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Please note down the point. Hope you all can see the screen. Law of conservation of mass states that okay. Law of conservation of mass states that mass can neither be created nor destroyed in a chemical reaction. Please take a note of this. Done, students? Okay. In order to understand this particular statement clearly, let me share my screen. Hope you all can see my screen. What is it mentioned here? Can you all read it out loudly? Yes, what is it mentioned here? Louder. States that Mass cannot be created or destroyed in a chemical reaction. ಒಂದು ರಾಸಾಯನಿಕ ಪ್ರಕ್ರಿಯೆ ಮೂಲಕ ಮಾಸ್ ಅನ್ನುವಂಥದ್ದು ಸೃಷ್ಟಿ ಮಾಡ್ಲಿಕ್ಕೂ ಸಾಧ್ಯ ಇಲ್ಲ, ನಾಶ ಮಾಡ್ಲಿಕ್ಕೂ ಸಾಧ್ಯ ಇಲ್ಲ. So you have an example of firewood or fuel, wood fuel, as well as the residue of it. And both the kg here, the measurement here seems to be equal. This thing you can see. A classic example of matter being neither created nor destroyed is a chemical reaction like burning wood, as you can see in the picture, where the mass of the wood is converted into gases like carbon dioxide and water vapor and ash. But the total mass of all products equals the initial mass of the wood, and the oxygen is reacted with another example here is that baking soda and vinegar, where a gas, namely carbon dioxide, is produced, but the mass of the gas is what makes up the lost mass from the reactants. So reactants ಅಲ್ಲಿ ಆಗುವಂತಹ lost in mass ಏನಿದೆ that can be seen in this gas. Similarly, let us consider these examples in details and learn about it. First one is combustion of wood. Combustion of wood ಅಂದ್ರೆ ಮರದ ದಹನ ಕ್ರಿಯೆ ಮಾಡೋದು. When a tree burns, it appears to lose mass, leaving only ash. However, if you would collect and measure all the gases released, namely smoke, water vapor, and the ash, their total mass would be exactly equal to the mass of the original tree plus the mass of the oxygen that fueled the fire. Next example, what we discussed was baking soda and vinegar. Mixing baking soda and vinegar in a sealed container with a balloon on the top will show the balloon inflating as carbon dioxide gas is released. If you weigh the container with the balloon, the total mass remains the same before and after the reaction, providing that matter from the baking soda and vinegar was simply rearranged into new substance. So, ಎರಡು ವಸ್ತುಗಳು, like for example, I'm giving you as an example, take an assumption. Your vinegar is 50 gram, baking soda is 50 gram. Together, you mix it, it becomes 100 gram. So, in this way, this is going to work. Next, third example is formation of water. To make a water molecule ಯಾವುದು? Two atoms of hydrogen and one atom of oxygen. Okay. The total mass of the hydrogen and oxygen atoms used will be exactly the same as the mass of the resulting water molecule, as the atoms themselves are conserved, not created or destroyed. So, ಈ ರೀತಿಯಾಗಿ ನಾವು ನೋಡಬಹುದು. And next is melting ice. This is a physical change. A block of ice has a certain mass. As it melts into a liquid water, its mass does not change, it only changes from a solid to liquid state. Okay. So, ಈಗ I have two ice cube which weighs 100 gram. ಓಕೆ, ನಾನು ಇದನ್ನ ಫ್ರಿಡ್ಜ್ ಇಂದ ತೆಗೆದು ಒಂದು ಪ್ಲೇಟ್ ಅಲ್ಲಿ, ಒಂದು ಸಾಸರ್ ಪ್ಲೇಟ್ ಅಲ್ಲಿ ಹಾಕಿದ್ರೆ, ಸೊ ಏನಾಗುತ್ತೆ, the room temperature it becomes water, and when you weigh the water also, that shall be 100 gram only. Clear? So you're understanding the difference. So what happens here? The mass does not change, it only changes from the solid to the liquid state. When the water eventually evaporates, it becomes water vapor and its mass is still conserved. The water molecules themselves are not created or destroyed, they just change their form. ಸೊ ಒಂದು ಫಾರ್ಮ್ ಇಂದ ಇನ್ನೊಂದು ಫಾರ್ಮ್ಗೆ ಅದು ಚೇಂಜ್ ಆಗ್ಲಿಕ್ಕೆ ಸಾಧ್ಯ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಓಕೆ, ಫ್ರಮ್ ಐಸ್ ಕ್ಯೂಬ್ ಇಟ್ ಇಸ್ ಟರ್ನಿಂಗ್ ಟು ವಾಟರ್, ಬಟ್ ದ ಮಾಸ್ ರಿಮೇನ್ಸ್ ಟು ಬಿ ದ ಸೇಮ್. Clear with everyone is clear with this particular topic? Here the mass is remaining to be the same, only there is change in the state of matter. So while I'm explaining the state of matter, so I wanted to rehydrate on a simulation which we had on explanation of the state of matter. How many of you remember? Okay, now tell me what are the various states of matter? Yes, please. Solid, liquid, gas. Okay, these are the different states of matter, and we all know solid is something like this. Liquid, gas. So, what is the difference you find out here? Solid is more rigid, liquid is comparatively less, and gaseous is completely freely movable. Isn't it? These are the understanding we make but by referring to this particular topic. But let me explain this with the help of a simulation. Hope you all can see my screen. 1 minute, give me a moment. Now, can you all see my screen? Okay. So what do you see there? You see a container filled with certain substance into it, and you see a thermometer, you see a pause and play button, you see heat and cold, heat or cold, right? So you see all these things here. Now here, the blue one suggests the neon, pink one argon, red one oxygen, and water, red and white. Okay, so which has two atoms of hydrogen and one atom of oxygen. Now here we have solid, liquid, and gaseous state. Solid is that very rigid and neat. Liquid is semi, in the sense it is here as well as that. Whereas gas state is extremely free. Got it? Now let us check one by one. For the better understanding, let me be in neon and let me go to the solid one. As you all see, there is a very less gap between one molecule to another, one atom to another. If I would heat this, you can see there's a slight movement in the particles, isn't it? What if it is in liquid state? What if I would start heating it? You can see there is a free movement. As well as gaseous state, which is completely in a free movement. When you start heating it, you can see the movement. You can also see there's a slight inclinement in the thermometer. So when you keep on heating it, there would be an inclinement in the thermometer. Can you all see, students? There's a slight movement in the thermometer. So these are the various forms: solid, liquid, gas. Okay. You can either put heat or put the cold on it and decrease the temperature. Okay. For a solid water, if I would put cold, what happens? It is going to get back the shape of the water, or if I would heat it, it would reduce the freeziness and get back into its original shape. This was about various states of matter, which is again a very important topic. Hope you are clear and understood about this particular simulation. Shall we move forward? Next, after learning the law of conservation of mass, let us learn about law of constant proportions. Law of constant proportion. Sorry, proportions. So, what do you understand by this? Lavoisier, along with other scientists, noted that many compounds were composed by two or more elements. ಎರಡರಿಂದ ಮೂರು ಎಲಿಮೆಂಟ್ಸ್ ಅಂದ್ರೆ ಧಾತುಗಳು. Okay. ಸೊ ಈ ತರ ಎರಡು ಮೂರು ಧಾತುಗಳು ಸೇರ್ಬಿಟ್ಟು you'll have a compound. So in a compound such as water, the ratio of mass of hydrogen to the mass of oxygen is 1:8. Please note down these questions may be asked in your exams. Okay. So whatever the source of water is there based on this. Thus, if 9 gram of water is decomposed, 1 gram of hydrogen and 8 gram of oxygen are always obtained. Similarly, in ammonia, nitrogen and hydrogen are always present in the ratio 1:4:3. So what are those? Ammonia, are you all noting this? So we have three things, ammonia, nitrogen and hydrogen, and these are available in 1:4:3 mass. So whatever the method or the source from which it is obtained, this led to the law of constant proportion, which is also known as law of definite proportion. Constant proportion or definite proportion. This law was stated by Proust as in a chemical substance, the elements are always present in the definite proportion by the mass. Okay. In a chemical reaction or chemical substance, the elements are always present in definite proportion by the mass. So the next problem that was faced by scientists was to give appropriate explanation of these laws. So again law ಮಾಡ್ಕೊಂಡಿದ್ದಾರೆ ಅದರ explanation conservation of mass and the law of definite proportion. ಈ ಟೈಮಲ್ಲಿ we have to all remember one particular scientist and his name was John Dalton. John Dalton. Can you all see my screen here? Sorry, not the screen. Just give me a moment. Yes, now can you all see my screen? This particular person is called as John Dalton. So, what is his achievement, ma'am? Why is he coming in our science book? So, the main achievement of the John Dalton is that he had born in a poor weavers family. Weavers and them ನೇಗಾರರು ಅಂತೀವಲ್ಲ ಅವರು. He began his career as a teacher at the age of 12, so almost ನಿಮ್ಮ ವಯಸ್ಸು. 7 years later, he became a school principal in 1793. So Dalton left for Manchester to teach mathematics, physics, and chemistry in a college. He spent most of his life there teaching and researching. In 1808, he presented his atomic theory, which was turning point on the study of matter. So it's not just a small atom or a matter or what you learn. So you have to understand the efforts behind getting all this done, getting all the credentials done. Okay, whatever we give them, it's a peanut, but whatever they have given us, it's always worth. Got it? So this was about John Dalton. So now, according to Dalton's atomic theory, this is an important question. You may expect this question in the exam. Dalton atomic theory. ಏನ್ ಹೇಳ್ತಾರೆ ಅವರದ್ರಲ್ಲಿ? All matter, whether an element, dhatu, a compound, or a mixture, is composed of small particles called atoms. Okay, everything, including me, you, chalkbus, duster, laptop, board, everything, every single element or a compound or a mixture. It contains a very small particle, and we call that particle as atoms. Okay, the postulates of this theory may be stated. Enanta, all matter is made up of, you can note this down, tiny particles called atoms. I'm just writing the keywords here. So this tiny particles is nothing but atoms which participate in chemical reaction. Though they are tiny, they participate in the chemical reaction. ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? Second point, atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. So ಈ atoms ನ ಮತ್ತೆ ನಾವು ಡಿವೈಡ್ ಮಾಡ್ಲಿಕ್ಕೆ ಆಗಲ್ಲ. Okay, so they are indivisible particles, and these atoms can neither be created nor destroyed, same as energy. Atoms of a given element are identical in mass and chemical properties. So these atoms are identical. Identical ಅಂದ್ರೆ ಕಾಣುವಂತಹದ್ದು ಅಂತ. ಓಕೆ, ಸೊ ವಾಟ್ ಐ ಮೀನ್ ಕಾಣುವಂಥದ್ದು ಕಣ್ಣಿಗೆ ಕಾಣುವಂತಹದ್ದ ಇಲ್ಲ, ಕೆಮಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸ್ ಇಲ್ಲಿ ಅವು ಮಾಡುವಂತಹ ಕೆಲಸ ಇಟ್ ಇಸ್ ಐಡೆಂಟಿಕಲ್. ಓಕೆ, atoms of different elements have different masses and chemical property. ಸೊ ಬೇರೆ ಬೇರೆ ಎಲಿಮೆಂಟ್ ಇಲ್ಲಿ ಕಾಣಿಸ್ತಾ ಇದೆಯಲ್ಲ ಫೋರ್ತ್ ಪಾಯಿಂಟ್. ಓಕೆ, ಬೇರೆ ಬೇರೆ ಎಲಿಮೆಂಟ್ಸ್ ಗಳಲ್ಲಿ ಅವುಗಳ ಪ್ರಾಪರ್ಟೀಸ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಸೊ ದೇ ಹ್ಯಾವ್ ಡಿಫ್ರೆಂಟ್ ಮಾಸಸ್ and chemical property. Okay, atoms combine in the ratio of small whole numbers to form compounds. In ಎರಡೇ ಪಾಯಿಂಟ್ ಇದೆ ಮಕ್ಕಳೇ, just we have 2 points. I won't take much time of yours. Just give me a minute back. Okay, what do we understand here? atoms combine in the ratio of small whole numbers to form compounds. So what is whole number? You all know what is whole number is? Yeah, we have our max teacher here only. So you have to tell yes itself, isn't it? So atom combine the ratio of small whole number. They combine whole numbers to form what? A compound. Okay. And the relative number and kinds of atom are constant in a given compound. It is also important. So atoms ಯಾವಾಗ್ಲೂ in a given compound, what will they be? Constant, fixed ಆಗಿ ಇರುತ್ತೆ. Okay, in a given compound. So this chapter is all about atoms and molecules. In our next class, we shall learn about atoms in depth. ಓಕೆ ಆಟಮ್ಸ್ ಬಗ್ಗೆ ಇನ್ನೂ ಡೆಪ್ತ್ ಆಗಿ ನಾವು ಅರ್ಥ ಮಾಡ್ಕೊಳಕ್ ಹೋಗೋಣ ಅಂಡ್ ವಿ ಶುಡ್ ಆಲ್ಸೋ ನೋ ದ ಸಿಂಬಲ್ ಆಫ್ ಸಮ್ ಎಲಿಮೆಂಟ್ಸ್ ಅದು ಸಹ ನಾನು ನಿಮ್ಗೆ ಈಸಿಯಾಗಿ ಹೇಗೆ ನೆನ್ಪಿಟ್ಕೊಬೇಕು ಅಂತ ಹೇಳ್ಕೊಡ್ತೀನಿ ಲೆಟ್ ಅಸ್ ಮೀಟ್ ಇನ್ ದ ನೆಕ್ಸ್ಟ್ ಸೆಷನ್ ಅಂಟಿಲ್ ದೆನ್ ಟೇಕ್ ಗುಡ್ ಕೇರ್ ಆಫ್ ಯುವರ್ ಸೆಲ್ಫ್ ಜೈ ಹಿಂದ್ ಜೈ ಕರ್ನಾಟಕ ಮಾತೆ ಜೈ ವಿದ್ಯಾಶಕ್ತಿ ನಮಸ್ತೆ